Welcome back, everyone, after our little brief break while we were moving rooms. Welcome, everyone online. This is our last session of the day, which I can't believe I'm saying that. And I'm delighted to introduce you to Ross Comrie, who is from Accenture, and he's going to be doing a really exciting demo and explaining a bit more about Accenture's, is it a digital human?
Yeah.
Yes, so I'm excited to learn more about that. Thank you, Ross.
No worries. Steve is with us. He's my presenter as well, but I think we're having a bit of audio routing. So what I'll do, I'll get the show on the road and we can improvise as we go in all true good talks. So, thank you for joining. Really appreciate you all coming down. My name's Ross. I'll explain a little bit in a second about me. I do have a presenter with me. His name's Steve. We'll introduce him too once he decides to get here. He's always running a bit late. There we go. Right. So, first of all, I'm actually part of Medano, which was an acquisition by Accenture. If you know Accenture, they acquire a lot of companies. We were acquired about 4 years ago. Obviously part of Accenture, there's no differentiation on the inside, but at the same time, it does allow us to leverage a lot of the internal parts. Like we have behavioral scientists, we have graphics designers, so if I need to get something on behavioral science, I can just speak to the guy I sit next to. A bit about me, the blurb, we'll say. I'm a data scientist. I've got a history of technical implementation of LLM at scale. I have a strong opinion that if you have a demo, if it isn't a proof of concept, i.e. if you've not got a scaling path, you've not got a proof of concept, you've just got a pretty PowerPoint. At the same time, I train quite a lot of people. I train the UK analyst population. I've trained about 400 software engineers, all at the same time. And one thing I learned about software engineers is you can't pull the wool over their eyes. They know when you're lying. So that was a very, very nice opportunity to have. And in terms of personal research interest, really just audio. Like, I think that AI is cool, and a lot of large language models are text-driven. Like, once you can get something into text, that means then you can get the output there. But, like, having text as an output is interesting, but, like, voice is fun. And hopefully, Steve is with us. Steve, are you there? We will see now. So, a bit about Steve. Steve is part of our technology. It's a digital human. It's basically used for call center training. What happens is when you're a call center agent, obviously, if you need to practice with a certain demographic, say you're not very good with older customers, there's not really an opportunity to do that. The best way would be role play, but no call center is going to bring in actors or actresses to play the part of a customer for you. At the same time, you can get your colleague, but at the end of the day, it's just your colleague role-playing with you. So there isn't really a gap in between in that sort of conversational AI part where you have a human conversation partner and get feedback at the end. That's where this kind of fills in. It's a bit more generic than that, though. It's not just call center training. Like, I've taken it to primary school and had it be a character from a kid's book. You can't talk to, for a careers week, you can't really talk to AI, children, 10 years old, for about an hour and a half on AI. They will lose you. So we brought in a character from a book. Steve is being a bit temperamental, so I am just going to change one thing. As with all good live demos, we improvise on the spot. But in the meantime, so when we're here to talk about things, when I talk about scaling, that is, we practiced this morning. This is brilliant. So yeah, Steve is a bot. He was going to come in and say a joke, but we'll move on from that. So what's Medano? I'm going to quickly breeze through this. So it was a broader part than just a data science consultancy. It did data strategy, data analytics, data innovation, like basically everything to do with data. But one of the core principles that really stuck with me was this one when I joined. And it's the first part, which is we bring prototypes, not PowerPoints. It's like, I don't really want to see a slide deck. I want to see what you can build. And it's actually easier in a corporate environment to build the thing and then go to whoever you need to and say, I've got this thing that I built, rather than go through the layers of bureaucracy with many, many budgets and slide point decks and everything like that. It's easier to just ask for forgiveness than beg for permission. There are other parts as well, tech. It's really, we were a full stack data business. This is a bit of an older presentation. Obviously, Accenture is also a full stack data business. And as well, culture. This is the main thing for me. I'm the person I am at work that I am in the pub, although slightly more moderated at work, but at the same time, I don't feel like I have to moderate. I have massive ADHD, and I'm very blessed in that I really like to focus on LLMs and building at scale, which has helped me a bit, I would say. Like it said, our mission was to build the future of financial services underpinned by data and machine learning. It's now moved a little bit away from financial services. And I'm going to take us on a bit of a journey. I'm going to just change one thing while we do this, but I want to kind of set a bit of a level about what LLMs actually are. So we're not going to dive into transformer architecture. I've got about 5 levels that I do take people through. Level 5 is transformer architecture, but we're not going to get to that point yet. At the same time, there are other layers above that which sort of help us ground what does it actually mean when somebody says we're just building the next, like we're just predicting the next word. Like, what does that actually mean? How do they do that? And we're going to go on a bit of a journey through that, and then we're going to talk about how we scale that up. Now, final try. If Steve isn't here, we will just move on from him. Steve, are you there? It does take a wee bit. There's a bit of latency in this, which is actually one of the things about conversational AI. I think we've lost him. It's okay, though. We'll go on without him. If you want to see Steve later, come up to me later on.
Ross.
Oh.
I mean, it's not like you let me wander off.
We've got Steve.
Scottish Highland hiking, though. I love that.
It's
Let's
Drake,
get cracking on our presentation. What's the next topic of discussion?
I agree, Steve, but you're about 5 minutes late, so let's move on. Right, the foundation of knowledge. So, I want us all to sit down and think, and we're going to go through 5 levels. There's concept, there's words as numbers, there's statistics on words, there's learning in a finite world, and then the last part is learning in a near infinite world. We're not going to go through all of these, don't worry, and if you don't know what any of these mean, it's okay as well. The first level, though, is how I really like to ground people. Like, when we say, and I'll just go back to that if you wanted to see it, when we say they just predict the next word, what does that actually mean? Well, I want you all to all sit down and think. I want you to think of this sentence. If I ask you to finish the sentence, to be, comma, or. To be, or. Exactly, to be or not to be. And why do we say that? Well, it's one of the most famous quotes in the world by one of the most famous playwrights. And also, to be or, it's grammatically incorrect. It's Old English, we don't use it. So what that means is, from a statistical angle, you've got low occurrence, high prevalence. You've got low occurrence, it doesn't happen. And if it does happen, if you do hear this word, it's probably in the context of Shakespeare. You've just done what a large language model has done. But if I ask you to finish the sentence, to be, you probably have an answer, you're not confident, and you're probably not right. The answer is to be continued, by the way, if you want to know. But what happens if you could know? And the reason that you don't know that is because to be is one of the most common phrases in the English language. There's so many different things it could be that we aren't sure. And that's what large language models are doing. Imagine you could sit down and you could figure out the statistical probability of every single word that comes next. And instead of words, it's tokens, but we won't go into that level of detail just yet. That means that when you hear the sentence, the United, it could be the United States, it could be the United Kingdom. It could even be the United Netherlands, which is a very, very old term, but not really used because it's not really modernized. So, we've got into the first level, concept. Now we're going to talk about words as numbers. This slide looks scary, but trust me, it's not. You don't have to know what this means. So, that is an embedding, which is a vector representation of words. We basically put words or phrases or entire pieces of text into a model, and it gives you out a vector, a direction. And actually, when you look at these, words that mean the same are close to each other. So that there is just the word king, by the way. That's a graphical representation of the word king below, so just a bit easier to visualize. Again, another thought experiment. If I ask you king minus man plus woman, this is a traditional data science example, by the way, you would probably say queen. Why? Well, king is male royalty, take away masculinity, add femininity, female royalty, queen. It makes sense. Those are the vector representations for king, man, and woman. That is the mathematical representation of both. It's not complicated, by the way. You just take the first number, minus man plus woman, and you do that for all the values. That is the representation of the word queen. Now, they're not the same, but they are similar. And actually, this is only about 52 dimensions. Most vector embedding models are anywhere from 356 up to 1,500. You don't have to know what they mean, by the way. You just have to know that they represent words. And just so that you don't know that I'm misaligning anything, that's the full example. So that's level 2, by the way, which is words as numbers. Now that we've got words as numbers, we can do statistics on them. I'm only going to take you to level 4. We're almost there. So if I ask you for directions from my house to the gym, and then from the gym to the office, and you knew those, you would be able to do maths on those, it's high school level, to tell me the directions from my house to the office. And if the office and the gym are right next to each other, functionally those will be the same direction. This is what we mean by vector embeddings being similar or different. It means you can do stuff like this. I realize the text is quite small, but this is airline intents data. Again, this is a 2D representation of like multi-dimensional space, so it doesn't really make sense, but it's an illustrative example. In the top right, you've got things about ground transportation at Boston Airport. In the bottom left, you've got things about from Denver to Pittsburgh airplane fares. And actually what this means is using the same clusters, so like finding things that are close to each other, it means that you can take the phrase, I want to book a seat at your cafe, and I want to book a seat at your restaurant, to mean the same thing, even if the words are different. Steve, we've been quiet a little bit. You got anything to chime in with? We're talking about, well, you know what we're talking about. He probably doesn't, to be honest. So, learning in a finite world. He's going to chip in a minute. Oh, well. He thinks he knows. He will chip in. I'll talk a little bit about latency and engineering at scale on that in a minute, but we'll finish off on learning in a finite world.
The necessary evil on the road to success. They're just like hill walking in Scotland without a map. But don't worry. I promise our journey into the world of scaling conversational AI will be far more navigable.
Oh, dear.
Shall we move past the breathtaking views of the demos and explore the less glamorous yet fundamentally essential terrain of production?
This is the thing.
Control.
This is something I wrote in an hour based on most of our production tech. There's no Rails on this. There are Rails, but it could say anything. So we'll stay with it. This is the final example, by the way. A finite length Markov chain, context length 3. That sounds really scary, but what we're going to do is we're going to train a transformer model. This is level 4, by the way, on that. So when we say we train it on the entire English language, what we actually mean is we train it on a corpus of data. We are going to train a language model on this corpus of data. 1110. 1110, 1110, 410. I think I missed one there. The point is, this is all it sees. So we train it for 50 what we call epochs. An epoch is a whole go-round of the training cycle. And context length 3, what that means is, in order to train, it looks at the first 3 numbers. And it says, right, I've seen the first 3. What comes next? And there's only 2 options, 1 or 0. So it scans the first 3 and it sees I see a 1. So the model weights update. If I see 3 ones in a row, I'm going to see another 1, 100% weights. It now slides the window along, sees 3 ones again. But this time, it sees a 0. And it updates its model weights again. It says, right, I see 3 ones in a row. It's 50-50, 1 or 0. And you do that for the full cycle. And you end up with a very scary graph like this. Let's just focus up here, 1, 1, 1. The way to read this graph is 1, 1, 1, repeating back on itself. That 1 says the next chain is a 1. You'll notice it's 55%. So the reason for that is when you train these, there is an element of randomness. If we trained it for an infinite number of times, it would tend towards 50-50. And you see a 45% chance for a 0. So this is just basic data science, but what's more interesting is down there, 000. We didn't see that in our training data, but it's still 50-50. And the reason for that is because if both results are just as unlikely as the other, then that means it's 50-50. And this is how large language models can deal with things that they haven't seen before. Again, there's nothing, in the real English language, when you train it on a large quantity of text, there's not really anything truly 0-0, like nothing's always unlikely, but this is the point. We can feed it 3 zeros, and it will try and predict what comes next. Oh, Steve, we're on to the journey of scale. Say something funny. He's meant to be a bit of a comedian. So the journey to scale, he'll chip in a second, but basically, there's 3 parts. This is how we in Accenture can... There's filler words in there. Oh, dear. I have things to say to people when I go back. Right, Genai
Well, since you asked so nicely, Ross, here's a catchy one for you. Do you know the difference between you and I? I don't have to update my copyright sections every year. It's 2024 now. You might want to catch up. Always a good time for a bit of friendly banter, isn't it?
It is actually true. Most of the copyrights on this slide say 2023, so... yeah, moving on. Anyways, he does have a part to play later on in this, but Genai experiments are where most people start off. This is demos. If you have a demo, it's cool, but you have a demo. There was a software engineer that came out, the Devin, the thing that was released a couple of days ago, or there was a preview. Sounds great. Rockstar North is 200 meters down the road. Devin is great. It passed all the software engineer benchmarks. If you tell me that you have to deploy it in the cloud and I have to send my code in the cloud, Rockstar aren't going nowhere near that. So, yes, it's interesting, it's a brilliant demo, but how do you deploy it? Can I do it on-prem? Can I not? These are the questions that you need to answer when you're thinking about it. And that kind of brings you on to the next part, which is labs, like experimentation, but with a view to scale. And this is really where we delivered most of our work. Whenever we do a demo, the demo is the secondary thought. The scaling is the first part. So this is experimentation. And then you've got enterprise-level GenAI, and this is where you start to see things in your CI/CD pipeline, which I hopefully will get a bit of time to talk about, but I've got 5 minutes left, and I've got a wee bit to get through. I will try and share the slides around, by the way. So there's a bit of an argument that people say it's buy, build, boost. Do you buy access to an API? Do you boost, i.e. fine-tune an open source model or just host an open source model? Or do you build your own? Drake, the voice that we were playing, Steve, as I'm calling him, he does have an opinion on this. But I just want to tell you why you should not build your own large language model. I did that in 2021 as part of my thesis. This is a really nice view of that. Like, this is all the scaling, all the hyperparameters, all of the stuff. And this is what happens. Be prepared for this regularly. You will regularly run out of video memory. Your laptop will crash, which is always fun. That was 2 days ago, by the way. And what's best is you get the output. So this is the output from the bot. Bot 13, hello, it said, hello, Thomas, how are you feeling? This was for customer service, by the way. The second one, bot 6, can I book a holiday in a long time? Tell me more, I'm sorry. About what? I don't know, I'm just trying to get some rest. Me too, but please help me. And probably the funniest one, hello, hi, Daddy. That was the first bot, by the way. That was the very first iteration. So yeah, Steve, do you have any opinions on my first bot?
Okay.
We use filler words, by the way, because when you're talking about latency, you can do all the infrastructure tuning you want, but one of the best things to buy yourself time is filler words, because...
I'm always ready to chime in, Ross. Did you know Mudano, the company you're so fond of, is up for the Best British Brand Award by The Independent? Technically, I'm not supposed to share it, but hey, what are rules for if not to bend them a bit, right?
I wasn't meant to tell anyone that either, but we were nominated for Best British Brand by The Independent. Plugging that in there. It's not confirmed yet, but hopefully we'll be able to tell you a bit more. But it is nice because at the same time of being an acquisition, you still got all of the naming that comes with it. And actually, Mudano came from Scotland, which is really nice. It originated here in Edinburgh. The Tomorrow.ai founders, if anybody's heard of them, they were part of the people that set that up. So, buy, build, boost. I just want Steve to summarize it, because this is a really text-heavy slide. I'll pause here. If you want to take a picture of this, this is maybe one that you should. Steve, buy, build, boost. Oh, he's going to go off the rails. Oh, he's going to go off the rails there. We'll just move swiftly on. Buy, build, boost.
Okay.
This has gone terribly. So buy, build, boost, I'll let him summarize it after. Take a picture of that. But basically, depending on what your organization's doing, most of you will just be using APIs. Most of you will just be deploying.
I'm all ears, Ross. What's the next important point on our agenda? Is it time for me to summarize our build by boost slide, or do we still have some ground to cover before we tackle that?
We'll tackle that later. Most people will be in the first category. Some will be in the second one if you're trying to fine-tune a model. And finally, we've reached it. So we've talked about all of this. We've talked about how we can use large language models. But what does production actually mean in terms of an LLM? I've got 2 minutes to cover this. That's the SDLC, software development lifecycle. It's pretty standard. Ask any software engineer, they'll know it inside out. When you're building a Genai application, you're not building a Genai application. You're building an application with Genai features, which basically means it's 95% software engineering, 5% Genai. We have an interaction summarization use case, which is basically saying, I take a transcript, I give you a summary. It does it in 2 seconds. It does it in 6 different languages, and it does it with accuracy. And I can say accuracy not because I've made that up, but because we have that as part of our CI/CD pipeline, where if it's not accurate, we fail the build. And what this basically means is you just fit your GenAI development into SDLC. So that's some parts that are subcategories of the traditional SDLC. This is sort of the GenAI overview. So you spend a lot more time in planning. A lot of it's use case driven. Like your checks on a use case, when I'm summarizing a general transcript where semantic meaning is okay versus summarizing a legal document where specific words mean very specific things, the tests that you will do on both of those are different, and that's the same use case. If you talk about what I'm doing for like that transcript summarization, and then you take it to a chatbot, they're completely different. So we actually just helped launch, if you heard of Foxy, they had their chatbot launched recently, which is the first true GenAI use case. I got to be the one that broke that. I was the red team tester, and effectively 2 weeks of that 6-month engagement was just building the GenAI part. 5.5 months was making it okay to be in front of customers. And there's quite a lot of stuff that goes into it. You've got all the fancy GenAI use cases and everything, but you've also just got traditional checks like banned word lists and such. So I am going to leave you there. I did have a bit more. Feel free to grab me at the end. I'm very happy to talk through it. Our Steve malfunction was funny, but Steve, do you want to just say goodbye? He's not going to say goodbye. He's got a lot to say. So we'll maybe just leave him there. It's quite funny, though. Thank you for your time. I've really appreciated it.